This will be our review for test 4, beginning algebra. So we have 2 to the negative 3 power. So this negative exponent, this means take this and move it across the fraction line. Remember, we pretend like this is over 1. So when we move it, the 2 to the third power is now in the denominator in the bottom. So if we move everything to the bottom, there's a 1 left up top. And now we just simply simplify. We say this is 1 over 2 cubed. Remember, that means 2 times 2, which is 4, times 2, which is 8. And then there is our final answer. It is 1/8 for this one. We have, again, a negative exponent. What do we do with the negative exponent? We move it. So this goes down. This one here moves up. So we're left with 3 to the third down here and 8 squared in the top of the numerator. So now again we simplify those. We say, what is 8 squared? Well, 8 squared is 64, 8 times 8, right? And here 3 cubed is 3 times 3 is 9, times 3 more is 27, and nothing will divide into 64 and 27, so that is our final answer. All right? So we have now w to the 5th and w to the 12th. Do we have any negative exponents? We do not. So what we do is we look and we say, okay, what do I do when I divide like bases? So w and w are like bases. I subtract the exponents. So here I'm going to have w, and why did I put this in the bottom or denominator? Because 12 is bigger than 5, right? So then that tells me when I start dividing this, I know that my w's are going to be left over down here because that's where more of them are, right? These 5, get rid of 5 of these and leave me with 7 is what's going to happen. So there's a 1 left up top. Anytime you divide everything out, there's a 1 left. So then this is going to be 1 over w to the 7th power. So 1 over w to the 7th. So here, p to the negative 7, p to the 6. The p to the negative, but remember, pretend like this is over 1, that's going to move down, right? So this becomes p to the 6th. That doesn't go anywhere. It's not negative. It stays where it is. P to the 7th goes down to the denominator. So we have p to the 6th over p to the 7th, and that equals 1 over p, right? Because we do, I should have shown that. Let me show that. This is going to be 1 over p to the 7 minus 6, and again, bigger number 7, so we put it in the denominator. So it's going to be 1 over p to the first, which is 1 over p. Then we have m to the negative 5 over m to the 8. Again, we have a negative exponent, so we take this and we do what? We move it. So the m to the negative 5 becomes m to the 5th down here, right? What about this m to the 8th? What do we do with it? Do we move it? No, we leave it where it is because that's a positive 8. So we're going to take this and leave m to the 8th down here. So again, if I get rid of everything in one place, it's going to be a 1 left. So this is going to be 1 over m. Now what do I do when I have like bases? I add them. Even though it's both in the denominator, they're in the same place. So I add them, 5 plus 8. So that is going to be 1 over m to the 13th. So 1 over m to the 13th power. So then here, x to the 23rd over x to the 9th. What do I do when I have like bases and they're divided? There's no negatives to move here, so I just go straight to subtraction. Now why don't I put this in the bottom? Because 23 is bigger, and it's where? It's up top in the numerator, so there's nothing left in the denominator here. It's like a 1, which we don't write. So this is x to the 23 minus 9 is 14, so that is simply x to the 14th power. And while I'm thinking about this, this is a rule problem. This is, that's the only rule, quote-unquote rule problem on that page. The first problem, the red one, is sort of like that. Here, what do I do with y to the 5th times y to the negative 11? I'm going to take this y to the negative 11 and I'm going to move it up. Because it's in some place, it's in the bottom, it's in the denominator, and I move it to the top of the numerator because it's a negative exponent. The y to the 5th stays. It doesn't go anywhere because it's already positive. So the y to the 11th comes up, and y to the 5th stays up top, and it doesn't matter which order you put that in. Now there's nothing left in the denominator. At the bottom there's a 1, so we don't write it. This is y to the 11 plus 5, because again, if I have like bases, I add these exponents. Add them. So this is going to be y to the 11 plus 5 is 16. So y to the 16th power. And then 40d to the 5th over 20d to the 7th. So look, this is still one term, but it is 40 as a factor and d to the 5th as a factor. That's two factors, okay, but one term. So anytime it's one term, you can divide. So we're going to take each factor, say 40 and 20. What goes into both of those? 20. It goes into once. It goes into 40 twice. So 20 goes into 20 once. 40 goes into 20. I'm sorry, 20 goes into 40 twice. So we're left with just a 2. But right now we don't put the 1 in the bottom. We want to wait and see if we have anything left over. So when I move over to my d's, where are the d's going to be left over? In the bottom, in the denominator, because 7 is bigger than 5, right? So this is really going to be over d to the 7 minus 5. We subtract them, right? We could put it up here, 7 minus 5, and simplify it, right? So let me do that. Let me put that up there in that case. You know what? I'm actually going to leave it for now. So then this is going to be what? Equals 2 over d squared. And we don't move that as a positive exponent. Don't move it. 2 over d squared. X to the negative 27. This is another just rule problem. This is a rule problem, the first one on the left here, and then this right here is a rule problem. What is the rule for negative exponent? You take this and do what? You move it down if it's over, act like it's over 1, right? So this is going to be x to the 27th down here, and then what do you have left over if you move everything a 1? So that's just 1 over x to the 27. 1 over x to the 27. And then this problem here, this one is just like this one, just different numbers. So 10 and 80, does anything go into both of those? Yep, 10. 10 goes into 10 once, 80 8 times. So right now I have over 8. So I got to figure out where are my d's. I don't want to put a 1 up there unless there's nothing else up there. So what about my d's? I got 2 of them and 9 of them. The bigger power is down here, so that means the d's are going to be left over in the denominator, d to the 9 minus 2 down here, d to the 9 minus 2. And now I've taken care of everything, and there's nothing left up top, right? Everything's gone from the top, so I put a 1 up there. So this is going to be 1 over 8 d to the 7th power. 1 over 8 d to the 7th. And then 25x to the 13th, 10x to the 5th. This is the same type of problem. So the next two are just like the two that I just said were the same on the page before. So 25, or the screen before, I think it's on the same page on your review. What goes into both 25 and 10? That's right, 5 goes into both of them. 5 goes into 25 5 times, and 10 twice. So this is going to be 5. We already know we have a fraction, 5 halves, and we know that there's at least a 5 and a 2. Where are my x's left over? In the top, because 13 is bigger than 5, right? So then how do I do this? I subtract the exponents. X to the 13 minus 5. That's going to be x to the 8th power. So 5x to the 8th over 2 is my final answer here. And then right here, I have 12 over 21. What goes into both 12 and 21? That's right, it would be a 3. 3 goes into 12 4 times, and 21 7 times. So again, I know I have 4 sevenths. And then how many g's are left? Well, g to the 3 minus 3, that's g to the 0, and we know that equals 1. 1 doesn't change it, so it's 4 times 1 over 7. That's just 4 sevenths. So my answer is just 4 sevenths. Then I have 18 v to the 6th, c to the 12th, 24 v to the 5th, c to the 2nd. It's the same problem, it just has another variable involved. So what goes into both 18 and 24? Same type of problem, I should say. 2 does, 3 does. So if 2 and 3 both work, 2 times 3 is 6. 6 does anything bigger than 6? Nope. So if we take a 6 out of this, 3 times 6 is 18, and 4 times 6 is 24. So we have 3 over 4. And then where are my v's left? Well, look, 6 is bigger than 5, so it's left up top, right? So how do we do it? We say v to the 6 minus 5, which is v to the first. And then what about c's? Well, again, c to the 12th is bigger than 2. 12 is bigger than 2, so it's left up top. So this is going to be what? C to the 12. That doesn't look like an exponent, so I'm going to rewrite it because exponents are raised. C to the 12 minus 2 is c to the how much? That's right, 10. And there's nothing else left. So 3v c to the 10th power over 4. So the next one has d to the 7th over c to the 4th, and it's in parentheses to the negative 3 power. So if it's in parentheses, that means that everything in the parentheses gets raised to that power, right? So that means I'm taking this negative and applying it to this and this. What does a negative exponent mean? It means if it's in the top, put it in the bottom. That's numerator to denominator. Or if it's in the bottom of the denominator, move it to the top of the numerator, right? So what we're going to do is I'm going to rewrite this fraction to the positive 3. When I go from negative to positive, I flip it. The fancy math word is reciprocal, okay? So if I want to flip it, then I'm going to put c to the 4th in the top now and d to the 7th. That's all you do. If it's in parentheses and there's a negative exponent outside the parentheses, you flip the parentheses, but you simplify inside the parentheses first, quantitative order operations. There's just nothing to do on this one first. So then if you recall, we did this where we did c 4th to the 3rd power, and then we also did d to the 7th to the 3rd power. And now we recall, how do I do one base with 2 powers? That's right, I multiply. This is going to be c to the 4 times 3, and d, same thing, 7 times 3. So that's c to the 12 over d to the what? 21 indeed. So c to the 12th power, and we want to make sure these things are raised. We don't want to write this. Right? This has to be raised, c to the 12th. See the difference? This is garbage. You can't have that, right? Got to make sure we write it properly. It's a detail. We got to pay attention to detail. So then what about x to the 5th, y to the 4th over x to the 3rd, y to the 9th, all to the 5th power? First thing I want to do is get rid of my negative exponents. That's what I like to do first. There's no negative exponents here, so then I'm going to simplify inside my parentheses. So I am leaving this thing to the 5th power because I'm not ready to change it yet. In fact, I want to write that higher up here. I want to write it up here. Leave it to the 5th power, give myself more room. So x is 5 and 3, so the bigger number's up top, x to the 5 minus 3, so that's x squared. What about y's? Well, the bigger number y is in the bottom, so there's going to be down here y to the 9 minus 4, which is y to the 5th. Y to the 5th. So then that's going to mean same thing we did right here to here, right? We're going to take each one of these powers, right, and multiply or raise it power to a power, which is going to end up being multiplying the powers. X squared to the 5th, right, and then y to the 5th to the 5th, which is x to the 2 times 5 over y to the 5 times 5. And I could use parentheses instead of dots there. That's going to be what? X to the 10 over y to the 25. X to the 10th over y to the 25th. Here again, I have a parenthesis to a power. There's no negative exponents. I have one term over one term. There's two factors. 8 is a factor and c to the 5th is a factor, but that's all one term because there's no pluses or minuses to separate those things in there. So, I went back too far. So here I'm going to take the 8 and the 12. What goes into both 8 and 12? That's right, 4. So 4 goes into 8 twice and 12 3 times. So I'm going to, again, rewrite this as something squared. I'm not ready to go to that squared yet. This is 2 and 3. How many c's are left? Okay, 2, and where are they? In the top, right? C to the 5 minus 3. So that's going to be c squared in the top because 5 is bigger than 3. Now, again, we have one term, two factors up top. 2 is a factor, c squared is a factor, but that's all one term. and then 3 is one term in the bottom. So we're going to take and do 2c squared over 3 squared. And if you remember this, I'm going to take everything and put it over that. Square it. So I'm going to do one more step. 2 squared, c squared, and 3 squared. And again, I'm showing extra steps here that some of you may skip, and that's okay. But I'm just showing you all the steps here. Taking this 2 to this power and then this to this power. All right? So what is 2 squared? Well, that's 2 times 2 is 4, but it's this 2 times it's this 2 right here times itself, not this 2 times this 2. All right, that's something different. And then over here, c squared, you multiply those 2's and you get c to the 4th power. And then what is 3 squared? 3 squared is 3 times 3, which is 9 indeed. So there's your final answers. Then we write it in our answer blank, 4c to the 4th over 9. So the next one has negative exponents. I need to simplify inside here because of order of operations before I do anything else. And I like to get rid of my negative exponents first. So I want to first eliminate this before I do anything else. That means move it where? Move it down. So this is x to the 5th over x squared. I'm going to leave that alone right now, even though I could have dealt with that because x's are separate than y's on factors there. And I have a y to the 4th, and my y to the 3rd stays down there, and this stays to the negative 3 because I haven't gotten to that yet. I've got to simplify inside, so I'm going to keep having negative 3 powers until I get down there. So then this is going to become what? Well, I'm going to put these two things together, and I'm going to put these two things together. So x to the 5th over x squared. I'm going to start with this. How do I divide them? I subtract the exponents, x to the 5 minus 2. And why is it up top? Because 5 is bigger than 2, right? So then this is going to be x to the 3rd. And this is still all to the negative 3 power, by the way. And what about y to the 4th times y to the 3rd in the bottom? What do you do with like bases? You add that. This is going to be y to the 4 plus 3, which is y to the what? 7. Y to the 7 indeed. Now this problem looks just like this one did when it started, right? And what did we do? We took this and made it positive, and we flipped that right there. So guess what we're going to do over here now? Now that we've done all that work, we're going to take this and flip it and make this positive. Wrong back button. Finally, sorry about all the screen flipping there. I've hit the wrong button. So this is going to be y to the 7th over x to the 3rd. And when I do that, I change that negative 3 exponent to a positive 3. And now I take and raise the top and the bottom, the numerator, the denominator, both to the 3rd power. So this is y to the 7th to the 3rd over x to the 3rd to the 3rd. And again, I'm showing some extra steps here. Y to the 7 times 3, x to the 3 times 3, because that's what one base with 2 exponents is, multiply the powers. So that's going to be what? Y to the 21 over x to the 9. Let me fix that 9. So y to the 21 over x to the 9th power. So here we have 3 terms over 1 term, right? There's just 1 term down here. When there's 1 term, remember the easiest way to do this is to break every term. So the first term is 20x to the 3rd over 5x. Then we have this minus. So it's minus 15x squared over what? 5x. And then we have plus 30x over 5x. I'm going to make sure all these things are long enough and under everything and over everything and the way they should be. So then what do? Then 20 over 5 becomes a 4, and then this becomes x to the 3 minus 1. So this is 4x squared. And then minus 15 over 5 is 3. There was no other negative to deal with, so it's just going to be minus. And then here x to the 2 minus 1, which is x to the 1st. We don't write the 1. Plus 30 over 5 is 6, and those x's divide out and become 1s. You could do 0, power 1 minus 1 is 0 power, or you could just leave it. So that's 6 So then here we have the final answer, 4x squared minus 3x plus 6. The next one is also 3 terms over 1 term. So the way I'm going to deal with that is divide each term by the 4x to the 4th in the denominator. This is going to be 20x to the 6th over 4x to the 4th minus 24x to the 5th over 4x to the 4th plus 16x to the 4th over 4x to the 4th. And this 4 is almost too low. If I take my x and kind of go down the middle there, the bottom of that number better be real close to halfway up the x, because otherwise it's a little too low. So that one's kind of borderline. I'm going to leave it there, but I wanted to point that out and say that's sort of how I look at it on your test. I'm going to go halfway up that letter and draw a line, and if I have too much of it below it, that's a little bit, that's okay. But if I look down here and they're on the same level like this, where I do this line, and those are almost the same, that's too close together. Okay, make sure it's a raised exponent. Exponents are raised. So here 20 over 4 becomes 5, and then we do x to the 6 minus 4, which is what? X squared. So 5x squared. Then we have minus, and this is 6, and then this is x to the 5 minus 4 is just x, so minus 6x. 6 coming from the 24 over 4, x from the 5 minus 4 is x to the first, plus 16 over 4 is 4, and then x to the 4th over x to the 4th, that just becomes 1. Or if you wanted to say x to the 4 minus 4 is x to the 0, and that equals 1. And if it equals 1, you don't worry about it, right? Anything multiplied by 1 is itself. So there's my final answer, 5x squared minus 6x plus 4. So now we're going to use long division. We're going to long divide these things here. So what goes under my house here? X squared plus 7x plus 10. And outside is x plus 2. And if you recall, the very first thing we do is we look at the first thing out front, this x and this x squared. And we say, hey, what do we multiply by this to get this? All right? And that would be x. X times x is x squared. Another way you could do that is this whole dividing thing. Put the x squared over the x, and that says, oh, that's x. That's what we use here. So if I'm using x, I'm going to put it in my x column. There's my x's, right? Line them up. So x. Then I take this x and distribute it to both of those things. So what do I have? X times x is what? X squared. X times 2 is plus 2x. Then I cannot forget that I have to do what? Change my signs. Minus here, plus here, that cancels. If that doesn't cancel, you messed up. So now we go back and we say, okay, what is plus 7x minus 2x? We got a plus and a minus. That means we subtract. What is 7 minus 2? 5, and that's still x's because they're like terms, and 7 is larger, so it's positive. So then we bring down our plus 10. Now I look and I say, okay, what do I do to this x to make it 5x? Well, how do you make x 5x? You multiply by what? By 5. But what kind of 5? Positive, because this is a positive number right here, right? There's nothing in front of it, so it's positive. So 5 times x is 5x, and it's the first term. 5 times 2 is plus 10. Now what do I do? Don't forget you have to change your signs every time. Minus here. Minus here, this cancels. Plus 10 minus 10 also cancels, goes to 0. There's my remainder. My remainder is 0, so I don't need to worry about it. My answer here, this is just equal what? X plus 5. Now, if I'd had a remainder, I wouldn't have had room to write that there, but I did. So x plus 5. Maybe it's better to write it down here. Equals x plus 5. We'll just take it off up here. And then we have one more to long divide here. So again, under the house is going to be the 2x cubed, when 2x cubed minus 3x squared plus 8x minus 13. And then out front is x minus 3. So what do I multiply? What do I multiply by x to get 2x cubed? I need a 2 and an x squared. So I'm going to line it up with my x squareds here, right? So then I say 2x squared times x is 2x to the third, because you take this 2 plus this 1 to get this 3 here. Okay, not that 3, I'm sorry, this 3, because we're multiplying to get that. But that's why we did it, is to get x cubed, 2x cubed. Then we also take 2x squared times negative 3, which is negative 6x squared. And once I do that, then I do what? That's right, I change my signs. Minus here, plus here. That cancels. And what am I left with? A negative and a positive. You subtract. 6 minus 3 is 3, and this is x squared. And the bigger number is positive, so this is positive, although we don't write it there. We just think about it being positive. Then we do what? Bring down our next term. That's like bringing down the next 0 or the next number in division of numbers. We're just bringing down the next term. So then I look at this and go, okay, what do I multiply by x to get 3x squared? Well, I need the 3 and I need an x, right? I got 1x, so plus 3x. And remember, you'll never put x squared and then put another x squared. That won't ever happen. So you can only put x squared, and then the next thing has to be x or less. No x's. So then 3x times x, we're doing this one now, right? 3x times x is what? 3x. That's why I did it, to get 3x squared. Then 3x times negative 3 is what? Minus 9x, isn't it? Okay, what do I do next? That's right, every single time I've got to change these signs. Make that a negative and a positive. That cancels. What is plus 8x plus 9x? Those are like terms. They're both positive. Add them together, and you keep it like. 17x, and it's positive, and then you bring down what? Minus 13. Bring down minus 13. And then I say, how do I do this? Well, I gotta figure out, what do I multiply by x to get 17x? Well, that's pretty easy. I have the x already, so I need 17. What kind of 17? Positive. So then I take this and multiply it by both these, right? So 17 times x is 17x. 17 times negative 3 is negative 51. And then what do I do? I change my signs, make this a minus, this a plus. That cancels. Negative 13 plus 51. So 51 minus 13 is 38. The big number is positive, so it's positive. That's my remainder. So how do I write that answer? It's going to be, I don't have a lot of room here. It's going to be, I'm just going to write it in here, 2x squared plus 3x plus 17. And then my remainder is 38. And what kind of 38 was it? It was positive, so I'm going to put a plus. Plus 38 over, what did I divide by to begin with? X minus 3. So I've been writing this out here. So 2x squared plus 3x plus 17 plus 38 over x minus 3. I mean, I have that in my answer box. So there is the review for test 4 for beginning algebra. So good luck.